Welcome to Brain Vision.
Okay, so we're doing chapter 37, problem 48. It says, what is the wavelength of an electron at three different energies here? So for A, it says 20 electron volts. And so all of these energies are much less than the rest energy of an electron, because mc squared for an electron is 0.511 mega electron volts, and which is at least 2 to 3 orders of magnitude greater than all of these values. So because of that, we can use non-relativistic relationships, which means that we can use equation 37.7 to calculate the wavelength. So non-relativistically, the kinetic energy can be written as p squared over 2m, or we can write p as the square root of 2mk. We can also write from equation 37.7 lambda as h over p, which then becomes h over square root of 2mk. Cool. So now all we have to do is calculate these. So for part A, our kinetic energy it gives us is 20 electron volts. So our wavelength now is 6.63 times 10 to the negative 34 joule seconds over square root. And we're going to have 2 times 9.11 times 10 to the negative 31 kilograms is the mass of the electron, times 20 eV. And now I'm going to convert eV to joules by multiplied by 1.6 times 10 to the negative 19 joules per eV. Cool. So if we plug that in, we get a wavelength of 2.7 times 10 to the negative 10 meters. Awesome. Let's move on. Part B. Now we're going to use a kinetic energy of 200 electron volts. So we're going to plug in the same thing here. And try and write this fast. All of it's the same except this 20 we're changing to 200. Plug it all in. Now we have 200 electron volts. And convert back to joules. And that's it. We plug all that. That's seconds. Plug all that in our calculator, and it comes out to being about 8.7 times 10 to the negative 11 meters. Okay. And one more energy to do, and this one is a kinetic energy of 2.0 kilo electron volts, or 2,000 electron volts. Okay, so again, we can see here, this is going to be the same thing, 6.63 e to the negative 34. We have 2 times 9.11 e to the negative 31 times 2,000 EVs and convert back to electron volts, 1.6 e negative 19. That was my little shorthand, so I didn't have to write all the same exact scientific notations over and over again. But if we plug this in, we should see, which you should expect, 2.7 times 10 to the negative 11 meters. Why should you expect this? Well, this is 100 times greater energy than part A. And if it's 100 times greater energy, the energy is square rooted on the bottom, so it should be 10 times less, which we see exactly here, exactly 10 times less than part A, or 1 order of magnitude less.